and you were supposed to simplify that. Now, this has no radicals in it, but if you were to simplify this, you look for like terms. Oh, look, these two have the same variable part. So we have 3x squared, and since this is, remember, adding, you can rearrange any order you want and group any way you want. If it's subtracting, you'd write it as plus a negative, and then you can rearrange it and group it because it's addition. But addition is commutative and associative. But you know that. We've gone over that. So these two are like terms, so we can write 3x plus 2x squared. We're going to add those together. And the 5x and the minus 3x are like terms, so I could rearrange the problem like this, and I'm grouping these two like terms and these two. Because they're like terms, and I can factor the x squared out and say 3 plus 2 x squareds. I just add the numerical coefficients. In other words, when they're like terms. Same deal here. I have 5 minus 3 x's, just factor the x out. And then we'd end up with 5x squared plus 5 minus 3 is 2x. Now, you know how to do that. We add like terms. Well, we can also, when we have problems involving radicals, we can add like radicals. Suppose we had 7 times the square root of 10x plus, let's say 3, or let's even say minus 3 times the square root of x minus 4 times the square root of 10x plus 1. Let's say you're supposed to simplify that. Well, you look for like radicals. None of these radicals would be simplified, but notice these two radicals. Radical parts they're the same. They're like radicals. Same index, both square roots, same radicand. So let's rearrange the order of this. And you don't even have to do that. You can just subtract them. But I could rewrite it like this. 7 times the square root of 10x, using properties that we know, associative and commutative addition, even though there's subtraction here. Minus 4 times the square root of 10x, moving that over there sort of, minus 3 times the square root of x, plus 1. Then we can combine these two. Just like over here, you probably wouldn't put all these steps in. You'd probably just say 3 plus 2, 5x squared. 5 minus 3, x's, 2. Here you just say 7 minus 4, 3 square roots of 10x. But technically what you're doing is you're factoring out the square root of 10x. That's why it works. It's really using the distributive property and factoring that out. Minus 3 times the square root of x plus 1. 7 minus 4 is 3. 3 times the square root of 10x minus 3 times the square root of x plus 1. I've simplified it. These two cannot be combined because they're not like radicals. That's just square root of x, not square root of 10x. It has to have the same index and the same radicand. Okay, but there's an example. See what else I have here. Let's say we have a problem like this. Here, let me make one up. Let's say, let's do another square root. Let's say we have 4 times the square root of 50, and let's say minus the square root of 8. And you're supposed to simplify that. Well, they're not like radicals. But both of those radicals, neither of those radicals are in simplest form. So let's simplify each one. Now we've done this before. I'm going to do it real quickly here. 50 is 25 times 2. So I can write the square root of 50 as 4 times the square root of 25 times the square root of 2. 8 is 4 times 2. So I can say minus the square root of 4 times the square root of 2. So square root of 25 is 5. So this becomes 4 times the square root of 5 times, 4 times 5. The square root of 25 is 5. So 4 times 5 times the square root of 2 minus square root of 4 is 2. So minus 2 times the square root of 2. That becomes 4 times 5 is 20 times the square root of 2 minus 2 times the square root of 2. And once I simplify, they're like radicals. They both have a square root of 2. And then you can use a distributive property like we did up here. But really, you just have 20 minus 2. That's 18 square roots of 2. You have 20 of them minus 2 of them. And you just end up with 18 times the square root of 2. That's simple. Okay? All right. Let's try maybe a cube root. Let's put some variables in here. Let's see if I can pick one out of the book. Here's an example out of the book. It's a cube root of, let's see what this says, 16x to the fourth minus 7x times the cube root of negative 2x plus the cube root of 54x. Okay, these are not like radicals, but they're not in simplest form. So once we simplify them, we may have some like radicals. Now this, we're going to do this kind of quickly because I'm assuming you kind of understand the idea now. Biggest perfect cube in 16 is 8, so I'm going to write the 16 is 8 times 2. X to the fourth is not a perfect cube, but there's a perfect cube in there because the exponent is bigger than or equal to the index. So I'll write the x to the 4 as x cubed times x and take the cube root of each one of those. So this becomes the cube root of 8x cubed times the cube root of 2x minus 7x. Now there's a negative under there, and these don't have negatives, so this is really negative 1 cubed times 2x. So you can think of it as a cube root of negative 1 cubed, which is just negative 1. In other words, you can just pull that negative out of there. So I'll pull the negative out of there. It's just like negative 1 times the cube root of 2x. Everybody understand why? Because see, this could be written as the negative cube root of negative 2x. You could think of it as the cube root of negative 1 cubed times the cube root of 2x. And the cube root of negative 1 cubed is negative 1. If you have an odd root and there's a negative under there, you can just pull it out, basically. That's what it boils down to. And then 54 can be written as 27 times 2. X is to the first power, so there's no perfect cube there. So I can, in that, as a factor, so I can write that radical as the cube root of 27 times the cube root of 2x. Okay? So this becomes, the cube root of 8x cubed is just 2x times the cube root of 2x. Don't forget the little indices, which I did there and here. Don't forget those. And then minus a negative plus 7x times the cube root of 2x plus the cube root of 27 is 3 times the cube root of 2x. Whoops, 2x. Cube root of 2x, cube root of 2x, cube root of 2x. Factor it out of there. In other words, you're going to add the coefficients. But using the distributive property, I can write like this. 2x plus 7x plus 3 in grouping symbols times the cube root of 2x, just using the distributive property. That becomes 9x, 7x plus 2x is 9x plus 3 in a grouping symbol times the cube root of 2x. And there's an example involving a cube root. Okay? Okay. Let me do some multiplication problems. There's a couple of examples that I'm getting. Let's see. Okay, there's a section that says multiplying radical expressions. Let's take a look at that. Suppose you're supposed to multiply and simplify. I'm just going to write simplify. Let's say it's the square root of 3 times 5 minus 2 times the square root of 3. Suppose you're supposed to simplify or multiply and simplify this. Using the distributive property, I'll multiply the square root of 3 times the 5. And I'll write it as 5 times the square root of 3 minus, I'll multiply the square root of 3 times the second factor here using the distributive property. And that becomes 2 times square root of 3 times square root of 3. You can write it like that, like that. Or you could write it as 2 times the square root of 3 squared. But square root of 3 times square root of 3, we've went over this back in section 9.1, I think it was. Or square root of 3 squared. Squaring and square roots undo each other. When you square a square root, you get the radicand. This is 3. So we end up with 5 times the square root of 3 minus 2. And again, square root of 3 times square root of 3 is 3. Or square root of 9, but it's 3 So we have 5 times the square root of 3 minus 6. And there's the answer in simplest form. Okay? And I stole that problem from page 640. Or no, I didn't. I made that one up, I guess. But I'm going to steal the next problem from page 645. Here's one that says simplify the cube root of 2 times 3 plus the cube root of 4. Whoops, cube root. Again, distributing the multiplication. The cube root of 2 times 3. We'll put the 3 in front. You multiply in any order you want. Commutative property of multiplication. So we usually write the 3 in front when you have a product like this. 3 times the cube root of 2 or 3. 3 times the cube root of 2. Sorry, and then plus the cube root of 2 times the cube root of 4. I'm going to simplify this part. I can use the product rule. I leave the first term the way it is, 3 times the cube root of 2 plus the cube root of 2 times 4, which is 8. That's 2. So we end up with 3 times the cube root of 2 plus 2, and we're done. That's in simplest form. Let's look at this one. I'm stealing this one from the book again, from the same page. 3 plus 2 times the square root of 7 times 2 minus 3 times the square root of 7. Notice there are two binomials multiplied together. It kind of looks like something like x plus 2 times x minus 5. Doesn't it kind of look like something like that, except for we have radicals involved. When we multiply this, we use the distributive property twice. We memorize this word, as you know, FOIL, to help you remember how to do it. So let's use FOIL here, same thing. We're still multiplying two binomials. So F stands for first times first. So we're going to multiply the 3 times the 2. I'll even write it out for this first one. Outsides of these two. So we have 3 times, this is like a negative 3. So we have a positive times a negative minus 3 times 3 times square root of 7. Insides of these two, notice plus, no negative sign here, so it's just going to have positive times positive, positive. 2 times 2 times square root of 7. And then last times last, that's these two, positive times negative, so we're going to get a minus sign. We're going to get, or have 2 times square root of 7 times 3 times square root of 7, that's 2 times 3. And then square root of 7 times square root of 7, which is just as 7 again, but everybody see why we get that? Now simplifying, we have 3 times 2, which is 6, minus 3 times 3 is 9 times the square root of 7, plus 2 times 2, which is 4, times that square root of 7, and minus 2 times 3 is 6. This part is 6. Remember, square root of 7 times square root of 7 is 7. That's 6 times 7, 42. No radical symbol. Equals, let's even rearrange the order first. 6 minus 42, those are just both constants, no radicals, both, rational numbers. Minus 9 times the square root of 7, plus 4 times the square root of 7. I just arranged the order a little bit, because I can combine these two and those two. These are like terms, they're both rational numbers. And 6 minus 42 is negative 36. So this is just negative 36. And then we have, combining these two, so we have negative 9 of them plus 4 of them. Negative 9 plus 4 is negative 5. Minus 5 square roots of 7. And there's the answer in simplest form. Another example. These are kind of special products. Let's just make one up here. Let's say we have 5 times the square root of 7. Let's say plus square root of 3. And let's say it's squared. Let's do that one. Now, I've mentioned this to you many times. We had a problem, I don't know if it was x plus 1 squared or x minus 1 squared on the last test, and a lot of people wrote x squared plus 1 or x squared minus 1. I told you that over and over again. I warned you about that. Don't do that. X plus 1 squared means x plus 1 times x plus 1. You got to either memorize that special product and just write the answer down or FOIL it. This means 5 times the square root of 7 plus the square root of 3 times itself. It's 5 times the square root of 7 plus the square root of 3. That's what it means. So I suggest you even write it out like this to remind yourself of that and then FOIL it. You can also memorize, like a plus b quantity squared is a squared plus 2ab plus b squared and apply that. But why not just write it out and FOIL it? So first times first, 5 times the square root of 7 times 5 times the square root of 7. So 5 times 5, just rearranging the order of the multiplication, and then square root of 7 times square root of 7. That's first times first. Outsides, FOIL, FO, outsides, we have 5 times the square root of 7 times the square root of 3. Everything's positive, so plus 5 times the square root of 7 times the square root of 3. Insides of these two multiplied together, everything's positive, so we just get plus. We have 5 times square root of 3 times square root of 7 in any order. And then last times last, again, two positives, so plus square root of 3 times square root of 3 or square root of 3 squared. But you're going to get 3 now, or square root of 9, well, however you write it. But it's going to turn out to be a 3. Here we have 5 times 5 is 25. Square root of 7 times square root of 7 is 7. Plus 5. We want to put this in simple form. We don't want two radicals. They both have the same index, so we can write that as the square root of, I'm going to skip this step, just 7 times 3, 21. You're allowed to multiply those two radicands together and put it under one radical symbol. Same thing for this term. So plus 5 times the square root of 21 again, and then plus square root of 3 squared, or square root of 3 times square root of 3, square root of 9, however you choose to do it, but you're going to end up with a 3. Okay? Now we got a little multiplying to do, but let's see. 7 times 25, 4 times 25 is 100, so was that 175? I'll let you multiply that out, or you could, whatever, multiply it out. And then plus that 3, so I'll just move it over here because I'm going to add it to it anyway because these are both rational numbers. These are like radicals. So we're going to get plus 5 square root of 21 plus 5 more. We add whatever the coefficient of the radical part is. They're like radicals, though. 5 plus 5 is 10. 10 square roots of 21. And then 175 plus 3 is 178. So we end up with 178 plus 10 times the square root of 21. And we're done. A word of caution. Sometimes with a problem like this, I see students add the 178 and the 10 together. That is not true. If you say you had 178 plus 10 times 2, you know order of operations. You're supposed to multiply before you add. You don't say 178 plus 10 and get 188 and double it. You say 2 times 10 is 20 and then add it to the 178. So you can't add that 178 and that 10. It stays like this. Don't add the 178 and 10. This multiplication has priority over any adding. You do not add those together. Okay? All right. Here's another kind of special product. Let's take a look at this one. Let's say we have 5 minus the square root of 3. And by the way, you can use, for this one we just did, remember, a plus b quantity squared, you could memorize this special form. That's a squared plus 2ab plus b squared. Now, all I did, you just FOIL it to get that. But notice it's just the first term squared plus 2 times you multiply these two terms together, ab, and then plus the last term squared. So recognizing this as of that form, you could just square this. See, that's this part right here. Multiply these two together and double it. That would be these two. And then square the last one. And you get the same answer. But anyway, that's up to you whether you choose to use that special form. Back to this problem. 5 minus the square root of 3 times 5 plus the square root of 3. Doesn't this one remind you of a plus b times a minus b? Now you can FOIL that also, but the answer is here, I'll put it underneath, a squared minus b squared. We memorized that form. So when you have one like this, see, it's the same two this, the same, they're two binomials. The only difference is a minus sign between one pair of terms and a plus sign between the other. If I do this, I'm probably going to use this form I memorized because it's easier. Let me do that first. Since it looks like a minus b times a plus b, I square the 5, just like you square the a over here, minus, I square the square root of 3. Square it now. And it's a difference of those two. So that becomes 5 5s are 25, minus the square root of 3 squared is 3. 25 minus 3 is 22. Done. A number. A rational number. It doesn't even have a radical. You can FOIL these if you want. First times first. 5 times 5 is 25. Outsides, that's plus 5 times the square root of 3. Insides, that's minus 5 times the square root of 3. Last times last, positive times negative, minus square root of 3 times square root of 3. That's that square root of 3 squared. The two middle terms, they subtract right out of the problem. So you get 25 minus 3. You're right back to the 22. But anyway. Okay. Those are some of the examples in 9.5. And that's probably enough for this video. It's long and boring as it is. So anyway, hopefully I'll get this video uploaded to Canvas. I don't know how to do that. I'm going to have to try to figure out how to do it or get some help. But hopefully it'll be on there and you can watch it. And it'll help you with sections 9.4 and 9.5. And hopefully I'll be able to make another video involving 9.6, maybe a 9.7 for the next one. But that's the end of this one.